2, lesson 12-1. Number 1, consider the staircase in the Explorer. How would the function b of s and t of s change if the staircase were a spiral staircase going from the first floor to the third floor with the same height and distance between floors? Well, b of s is 0 plus 7.5x. Okay, so that starts at the bottom and goes to the top. So there would not be any change there. T of s, let's see what's T of s. T of s is 105 minus 7.5x. Now, 105 is the height of the second floor. But since we're going to the third floor, we're going to change that to 210. Okay? And let's see, with the staircase and first one, how would the function be? Now, what about the range? Well, let's do the domain first. The domain. What's the domain? Well, let's see. The domain would change to 0, 1, 2, yada, 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 to 28, because there would be 28 steps instead of 14. The range would change as well, and it would be 0, 7.5, 15, and so on to 210 instead of 105. So that would be the changes. Let's go here to number 2. And what does it say here? Use the table to write an explicit and a recursive rule for the sequence. Well, first off, we need to check and make sure it is in fact arithmetic. To be arithmetic, it has to have a common distance. Okay? And if you take 1 minus -6, that gives you a distance of 7. 8 minus 1 gives you a distance of 7. 15 minus 8 gives you a distance of 7. And then 22 minus 15 gives you a distance of 7. So we can say that D equals 7. All right? D equals 7. We'll say D equals 7. Now we have to find, it starts at 0. We're going to say a sub 0 equals -6. All right. So the formula we want to use is f of n equals a sub 1 plus d times n minus 1. Okay. Well, this time we got 0, so that's going to change the formula a little bit. But we're going to have f of n equals, and this is a sub 0, that's going to be -6, plus, and then d is going to, d is 7, and then instead of n minus 1, since we started at 0, we're just going to have n. Okay? That's supposed to be a sub 1. And it's also bound from 0 to 4, so we're going to say 4, 0 is less than or equal to n is less than or equal to 4. Now the recursive rule, that's the explicit. The recursive rule is going to be slightly different, okay? And we're going to have f sub 0 is -6. And then f sub n equals f sub n minus 1 plus 7. and we're going to say 4, 1 is less than or equal to n is less than or equal to 4. So that's number 2. Number 3 is going to be, well, again, it starts at 0, so we're going to have a sub 0 equals 8. And then what do we got? 5 minus 8, that's going to be negative 3. And then 2 minus 5, that's going to be negative 3. Negative 1 minus 2 is going to be negative 3. And again, negative 3. So D equals negative 3. The explicit rule is going to be f of n equals negative 3, 8. I got it backwards there. 8 minus 3 times n. 4, 0 is less than or equal to n is less than or equal to 4. The recursive rule, we got f of 0 equals 8, and f of n equals f of n minus 1 minus 3. And that's going to be 4, 1 is less than or equal to n is less than or equal to 4. Number 4. Given the recursive rule for an arithmetic sequence, write the explicit rule. Okay, so let's look at what the explicit rule is. F of n equals, and since this starts at 0, we're going to use a sub 0 plus d times n. All right, so we need to find a couple things. F sub 0, that's really a sub 0, so a sub 0 equals 6, and then your d equals 5. So our equation is going to be f of n equals 6 plus 5n, and that's going to be 4n is greater than or equal to 0. Now number 5 has changed a little bit. It's f of 1. So let's make this a sub 1 plus d times n minus 1. All right, so a sub 1 is 19, d equals negative 10. That's the common difference. So f of n equals 19 minus 10 times n minus 1. And that's going to be 4. N is greater than or equal to 2. And I made a mistake over here. I did not finish reading that. N is greater than or equal to 1. And there we go. No, I had it right. That's right. Okay. Given the explicit rule for arithmetic sequence, the reason why that's right is this, remember, it gives you this one here, and then this rule is for 1 and so on. So, and if you put a 0 in there, you get 6, which is right. Here, if you put a 1 in, 1 minus 1 is 0, so that just gives you 19, and that's right. Given the explicit rule for an arithmetic sequence, write the recursive rule. Well, we need to find out what is the first term. A sub 1, and 1, let's see here. Let's see, it starts at 1 here, right? So we're going to say f of 1 is 9.6. So f of n is going to be 9.6, and then we got a 0.2 here. So we're going to say minus 0.2. I'm sorry. F of n minus 1 minus 0.2. And that's going to be 4. N is greater than or equal to 2. because it started at 1, right? All right. Here, let's see if we can do a little bit better. It starts at 0 here, right? So we got f of 0 equals 14. F of n equals f of n minus 1. And then we got 8, so we're going to add 8. That's going to be 4. N is greater than or equal to 1. Number 8, write these terms. Write the terms of the given arithmetic sequence and then graph the sequence. Okay. So let's write the terms. Starts at 0 here, right? So our first term is going to be 7. And we might do it like this. We might do it like this. You got x. Oh, let's do it like this. And we'll say y, or f. This is f of n. You can do it either way. X or f of n. So if x is, well, it starts at 0. 0, then we have 7. So 0, 7 is going to be right there. Now if it is 1, put a 1 in there, so we're going to subtract a half off. That's going to be 6.5. So 1 and 6.5. And if you put a 2 in there, that's going to be 1. That's going to give you 6. All right. Put a 3 in there. That's going to be 3 halves, so that's going to make that 5.5. And then you're going down a half each time. Okay. And there we go. And there's your graph. Now these are discrete. Discrete points. Okay. What about over here? So we can do the same thing. X and then f of n. And it starts at 1 here, right? So let's put a 1 in there. 1 minus 1 is 0, times 2 is 0, so we're going to have 3. 1, 3 is going to be right there. And if we put a 2 in there, 2 minus 1 is 1, times 2 is 2, plus 3 is 5. So 2 and 5. Put a 3 in there. 3 minus 1 is 2. 2 times 2 is 4, plus 3 is 7. So 3 and 7. Are you seeing a pattern now? Put in a 4, and that's 9. Put in a 5, and that's 11. 4 is 9. 1, 2, and over 1. 1, 2, and over 1. 1, 2, and over 1. Oh, we were supposed to stop at 5. So there we go. There is our thing. And that's because it stops at 5. We good? All right. Moving right along. A little happy there. 10. Boy, I tell you what. All right. Number 10. If f of 1 is 0.5, and so we're doing it recursive style now. So we got 1 and negative 0.5 is going to be right there. And we're going to go down 1/2. So you'll have 1 here, and then you're going to go down 1/2, and then down 1/2, and down 1/2. And for greater than 2, so we just take it all the way out. And there we go. What about over here? 0 and -5 is going to be right there. Now we're going to stop at 4 here on this one. F of 0 is 0.5. And then 1, let's see, we're going to add 3 to that. So 1, 2, 3, and over 1. 1, 2, 3, and over 1. 1. Oh, I did that too many. I did 4 on that. 1, 2, 3, and over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. And there we go. We stopped at 4. Number 12. Let's see. Thomas begins an exercise routine for 20 minutes each day. Each week he plans to add 5 minutes per day to the length of his exercise routine. For how many minutes will he exercise each day of the 6th week? So we're going to say F of 1 is 20 minutes. And D is going to be 5. So our equation is going to be F of n equals 20 plus 5 times n minus 1, because we started at 1, okay? All right, now we want to find how much he's going to work the 6 weeks. So we got 20 plus 5 times 6 minus 1. So F of 6, that's 20 plus 5 times 5, which is 25, plus 20 is 45. So Thomas will will exercise 45 minutes each day during the 6th week. The 6th week. All right, number 13. The Louvre Pyramid in Paris. The Louvre Pyramid in Paris, France, is built of glass panes. There are 4 panes in the top row. So we're going to say F of 1 equals 4. And each additional row has 4 more panes. So we're going to say D equals 4. Now, let's see. You could do it recursively, would be basically just adding 4 to each one. But it might be easier if you do an explicit rule. That's going to give you 4 plus 4 times n minus 1. Now, let's see. So F of 17 equals 4 plus 4 times 17 minus 1. And that's going to be 4 plus 4 times 16, which is 4 plus 64, which is 68. Okay? Not too shabby. Clarissa is buying a prom dress on layaway. The dress costs $185. She makes a down payment of $20 to put the dress on layaway and then makes weekly payments of $15. In how many weeks is the dress paid off? Okay, I want you to do that on your own, and you should show your work. And the answer is n equals 11. Okay, the dress will be paid off in 11 weeks. 15. The graph shows the height in inches of a stack of various numbers of identical plastic cups. The stack of cups will be placed on a shelf with 12 inches of vertical clearance with the shelf above. What number of cups can be in a stack having a tight fit? Okay? I want you to do this on your own. Show your work. And, well, I guess I'll go ahead and tell you. The answer is n equals 28. But like I said, you have to show your work to get credit. Folks, you've been wonderful. You have a good evening, and I'll see you tomorrow.